Alright guys, I want to spend a few minutes just kind of going through and looking at how to write skeleton reactions. We'll focus on balancing in a later video, but I just wanted to just kind of see if we can get some more practice in, because some of us are just having an issue with getting the naming down. Just to kind of keep as a reminder, naming hasn't changed. It's the same naming we did in the last chapter. All we're doing is taking the compounds and putting them into a formula. So let's just go through and analyze this first problem. We're told solid zinc. Zinc, of course, is element, that is Zn. We're told it's a solid. So the way we identify the state of matter is with the parentheses and the state of matter right after it. Not really a superscript or subscript, it's just kind of a small off to the side symbol saying that this guy is a solid. Now notice zinc does not have any charges or anything like that. It's just elemental zinc, which is just Zn, no charges, no numbers after it, nothing. The only time we have numbers after an element that's by itself is if we have a diatomic substance, which are the 007 we talked about, which is hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Only when those guys are by themselves. Remember that that does not change their charge based off the periodic table. When they're in a compound, we look at their charges. Alright, reacts with is our plus sign. Okay, and we're reacting with aqueous lead to nitrate. Alright, let's come down here and try writing lead to nitrate, because this is where some of you are just having some issues. Lead is Pb, which is that, and it is a +2 charge. Remember, anytime we see the Roman numerals with a 2, that is a charge of the transition metal. Nitrate is NO3, it's a polyatomic ion with a -1 charge. We cross and swap, and what we end up with is lead to nitrate is Pb, NO3, 2. Okay, now aqueous is just the symbol we put outside of that, which is AQ, showing that it's a solution. To form is our arrow, and we're forming zinc 2 nitrate. Again, zinc is Zn. Now it has a +2 charge because it's in a compound, so Zn2. We have nitrate, which again is NO3, -1. Cross and swap, Zn, NO3, 2. And again, aqueous, so AQ. And again is our plus sign, and that is going to be solid lead, which is Pb, no charge because it's the element lead, and parentheses solid. Okay, so that's our first equation. Let's look at the next one. We're given aqueous aluminum bromide. Well, aluminum bromide is aluminum, which is a +3 charge. Bromide is bromine ion, which is a -1 charge. Okay, so we cross and drop, and what we end up with is aluminum bromide is AlBr3, and it is aqueous, so AQ. We're reacting with chlorine gas. Now, chlorine is one of our diatomics. It's by itself. We know that by the INE. Notice this is IDE here, which is because it's in a compound. Remember, our anions, when they are in a compound, our anions in general have an ending of IDE. So if we see chlorine, INE, that tells us elemental chlorine, which is a diatomic, so Cl2. And of course, gas is a G at the end. It's reacting to form, so arrow, aluminum chloride. So again, let's go down here and write out aluminum chloride. Aluminum is Al +3, chloride is Cl -1, cross and swap, aluminum chloride is Al Cl3, and that is aqueous. Okay, and again, bromine, notice the INE, and bromine also is a diatomic, just like chlorine, so we do Br2, and gas, which technically, that's fine. Okay. Moving on, number 3. We're here given sodium phosphate. So again, let's go down a little bit further so we can write out our compound. Sodium is Na +1. Phosphate is PO4 -3, directly off our polyatomic ion list. Cross and swap, Na3 PO4. Okay, and that is aqueous. We're adding that to calcium chloride. Calcium is Ca +2, chloride is Cl -1. Notice I'm not doing anything with a 2 here with chlorine like I did up here, because up here chlorine is by itself. Here it's not by itself. Notice that it is, there it is, notice that it is chloride, so it's in a compound. So cross and swap, and we get CaCl2. This 2 is not because chlorine's a diatomic. This 2 is because calcium has a charge of +2, and you need 2 chlorines to cancel out that +2. Okay, and that also is aqueous. We're reacting to form calcium phosphate. So let's erase these guys down here. Calcium phosphate is Ca plus 2 phosphate, PO4, -3. Cross and swap, we get Ca3, parentheses, PO4, 2. And that is a aqueous substance as well. Okay, and we're adding that to sodium chloride, NaCl, or sorry, Na plus 1. Chlorine is Cl minus 1, or chloride. Cross and swap, NaCl, and aqueous. Okay, and last one on this page, we'll move this up just a little bit. We have potassium metal, which is just K, and it is a solid, because we're told solid at the beginning. And, plus sign, chlorine, again, notice the INE versus the IDE, so it's Cl2. And remember, again, that 2 is only when it's a diatomic, which is just those 7 elements that are diatomics when they are by themselves. They're combining to form, so arrow, potassium chloride. Well, potassium is plus, chloride is chlorine with a -1 charge, cross and swap, KCl, and again, solid. Okay, so far that's the first 4. Let's try another couple 4 together. Okay, so first one is aluminum, solid aluminum. So we have Al, and we draw our solid after that. Hydrochloric acid, remember hydro means no oxygen, which means chloric here is chlorine with a -1 charge. Acid, remember, tells us that there's a hydrogen out in front, cross and swap. We are adding this guy to HCl, and that is aqueous. To form is our arrow, aluminum chloride. Okay, well, aluminum is a +3 charge, chloride is Cl minus 1, cross and swap, aluminum chloride is Al, Cl3, and that is aqueous. Right, we're adding that to hydrogen gas. Remember, hydrogen gas is one of our other 7s. It's by itself, so it's H2. It's one of our diatomics. And then a gas at the end. Okay, next one, calcium hydroxide. We'll jump down here. Calcium is Ca plus 2. Hydroxide is a polyatomic ion OH with a -1 charge. We'll keep the monster in the box for right now. Cross and swap, we get Ca parentheses OH2, and that is aqueous. We're adding that to phosphoric acid. Notice no hydro here, which means we're looking at the ending. It's ic, so it came from 8. Phosphate is PO4 with a -3 charge. Acid, remember, tells us hydrogen down in front. So phosphoric acid is H3PO4, and that is aqueous. Okay, it's reacting to form, so arrow, calcium phosphate. Calcium has a +2 charge, so Ca plus 2. Phosphate is PO4, -3, cross and swap, Ca3, PO4, 2. And that is aqueous as well. Okay, and our last one is water, which is just H2O, and it is always a liquid unless otherwise noted. Okay, let's keep going. 2 more. Copper, solid copper is just Cu, and that is a solid. And plus sign, sulfuric acid, again, notice no hydro. So sulfuric came from sulfate, which is SO4, -2. Acid tells us hydrogen out in front. So we're adding this to H2SO4. Okay, to form is our arrow. Copper 2 sulfate. Copper 2 tells us it's a copper plus 2. And then sulfate is SO4 -2. Cross and swap. Remember that if we end up with the same number, or numbers that are divisible by each other on the bottom, like here, 2 and 2, they simplify into 1s in this case, so CuSO4, and then they're both 1s here. And we're adding that to sulfur dioxide gas, so SO2, and that is a G. Oh, we forgot states and matter on a couple of these, sorry. Aqueous for sulfuric acid, and this guy is also aqueous. Okay. And last one to practice. Okay, hydrogen gas, H2, because it's one of our diatomics. We're adding that to nitrogen monoxide. Notice here we have the prefixes, just kind of like we did up here with the sulfur dioxide, nitrogen monoxide. That tells us again that we're dealing with a covalent compound, so we don't cross and swap. We write it just like it is. So nitrogen monoxide is NO, and that is a gas, and is reacting to form water, H2O, and again a liquid unless otherwise stated, and nitrogen gas. And remember, nitrogen is also one of our diatomics, so N2 with a G after it. Okay, so hopefully this helped just kind of reviewing. What we've noticed is you guys are just having an issue writing out the names. Remember that aluminum chloride is the same aluminum chloride we dealt with last semester. So we're going to name it just like we did last semester. So don't let the fact that you're putting it into a reaction confuse you. Your naming rules have not changed. They're exactly the same as they always have been. So make sure you're using your periodic table to find charges or your polyatomic ion list as needed. And then if you have any questions, let us know. Thanks, guys.